two main issues, and one of them in the howto and the second in Ubuntu, and Python. Sorry, not Ubuntu.
Okay.
And the bloating. Can I share my screen?
Yeah, please share your screen.
Okay, let me share. Can you Apple participant to screen sharing?
Yeah, okay. Double check. Yeah, you should do now. You can do now. Yeah, please.
Yeah. Let me share. Okay. Okay. For each time, every time I want to draw the M1 and M2, I change the names. When I change the name of energy, like energy temperature 1 or energy T1, anything rather than energy, it shows me in Python too many arrays to the indices or too many indices in the array. Let me show you.
Wait 1 second. You have K0, KK, the same as what I do last time. You have N. Yes, so 1 and 2. So what's the issue? What's the
issue, Doctor? Each time I want to draw two energy dot, he shows me an error in the Python here and says that too many indices in the array.
What's the message? What's the error message?
Let me show you.
Yeah.
Okay, and in the howto, I don't know, you changed the radius to 0.2. I couldn't find how to change the radius.
If you want to plot 2, then you will have another file, energy 2 data, right? Something like that.
Yeah. I changed everything, and I tried many times, but does not work. Like for example, here I have 1.9175, 1.915, 1.92. Okay.
Well,
this is our
1.91. Yeah. Okay. L1. Yeah. So you should have L2. You have another. Yeah.
Okay. Let's say that M for the energy in the main file here, and let me, for example, try this one, or not this one. This one, and for let's say energy 0.92. Okay, and here I should write energy 0.92, and it should work now.
Yeah.
Okay. Now another error. He says that energy 0.92 does not found.
Yeah. Do you have the energy data code? Your have the name energy dot 92 is the file name. You should have a file.
Yes, here.
Well,
here energy.92, and here is the energy. And here is the Python, the Python code, untitled 6.
No. I did not see you. Where is your energy.92 data? Yeah.
Here. In the file of in the file which names 1.92. Should I make the energies, for example, should I copy the energy and paste it in here?
No, I did not see your mouse. So you said here, I did not see where put?
In file 1.92.
File 1.
Let me try this now. Okay. Now it's working.
Okay.
I tried many times, Doctor, but it does not work. But now it's working. Okay.
All right. Okay. Wait a second. Actually, you do have something wrong with your M1. You add something that's unfair. I mean, that's not good.
Which one?
The 917. 917.
Line 17 M1.
Yeah, that's one is what for my demo. That's not true. In your case, you should not have this one. Yeah.
So you mean I should?
Yeah, comment it. Yeah, you comment. Yeah. Can you please run again? Okay, that's more better. Yeah.
Okay, Doctor. Also in 555.
Wait 1 second. And 922.
922. This one.
Yeah. 922.
What should be?
So the arrow one have K.
And the second without K.
Without K, it doesn't make sense. Maybe
Yeah, it's now just to show the problem.
Yeah.
Now they're showing.
Yeah, much better. Yeah, much better. All right. So what's your next question?
Okay.
Yeah.
Here in the phase change 333, it is looking like it is good. Okay. In the phase change, but in temperature 555, the critical temperature was 1.9175. This one, but the points here, I don't know why it's messy, and it give me a strange numbers, like for 1.94, which should be an amorphous, and after the melting temperature, it gives me minus 4.8.
Now
I don't know.
It may not be that far from 9. It should around the 2. It will not go to 4.
Around 2. So here, last one.
No, your screen do not change. Could you please do it again?
Okay.
Your screen do not change.
Okay, let me just share. Now, does it change?
No.
Just 1 minute. What about now?
Yes, that is good. Yeah, 3.
Okay.
We saw a clear jump. Yes.
333, it's fine, but in 444, I don't know why. It is a strange behavior. The first one is looking good. Second one, it's fine, but the rest, I don't know. They are strange.
Okay, I think that this maybe the data you have not been equilibrium yet. You need more time. This is a very common issue. For 3 by 3, you may have 1 million. Equilibrium is be fine, but for 5 by 5, you may need 2 million MC steps.
Yeah, I have make it to 2.5 or 2 million. I already made that.
No, you have not. No, your steps, you're only 0.2. You only have 0.2 million. It's far from enough.
Why? It's 6. It is 2 million, Doctor, or not?
Okay, 2 million. 2 million should be okay. Yeah.
I don't know. I will show you the equilibrium.
Yeah. Please show me your equilibrium.
This is what I have got from Python.
Yeah.
It's here the jump.
Yeah.
And here is the equilibrium.
Yeah. So you can have the data only after, for example, after.
Yeah. 0.9. I estimated to 0.9.
No,
million.
no. You go a little bit later. You go after 1, right? It should be more equilibrium.
So like 1.1 or something.
Yeah, at least after 1. Yeah, you should put it in the flat. You know, in
The flat region.
yeah. So your previous. I mean, before
But
that data doesn't make sense. It do not need your just for the equilibrium phase. Then after that, after 1 million steps, then that will be equilibrium. I mean the production phase. So you can take that data only.
okay.
If
And
you do the data wrong, then your data will doesn't make sense because your data is not right. Yeah.
but Doctor, the plot here is looking good for the equilibrium and for the phase change, because it's like the jump is, it's not very obvious like in the 333. It's like the slope here is lower, while then 333 the slope was more more
Yeah,
vertical than
3 looks
horizontal.
good. Looks good. If you do something similar, you should find something similar for 5 by 5 by 5. Yeah, you should go ahead and take equilibrium carefully and take the average and do that. You should.
So Doctor, this is plot, and this temperature is not the equilibrium.
This temperature is not equilibrium, so the data, you only take the data after 1 million. After 1 million.
After 1 million, it will be equilibrium.
Yes, yes.
Okay.
So it's better. If it's better, you say 1.2 million. Then after, yeah.
Yeah, no problem.
Yeah. For each of your plots, each of your data, you should be take care. I mean,
yeah, I have done it for 333, and it was I think it was good.
No, each time is different. Yeah. Okay.
Yeah, but each all of them will be looking like this.
Okay.
Aren't they?
So not all of them, but you will sometimes if you get a good plot, you will have more points. Not only just here how many you have done. You have 1, 2, you have 7. Sometimes you need more data than that, and also you need much fine grade. I mean, you should do more details. For example, if you have the transition 1.9, you may go to 1.88, 1.89, 1.85, etc. You can go second digit. Yeah.
The problem, Doctor, is it takes a long time. For example, when I try to do the 888, my laptop hang.
Yeah.
Does not complete the simulation.
Yes. So you need to like 8 simulations simultaneously, right? You can do that. Use your hyphen, right? Use your send, right? You can.
I don't think, Doctor, my laptop will can carry the seminal. No. I don't think my laptop can do many simulation in one time.
Have you checked
because Doctor, as I said, when I tried 888, it does not. It's hang after maybe half an hour. It hangs, and I have to shut it down and start it and restart the laptop again to open to. It hangs.
Sometimes you can do that. Yeah, first please check how many CPUs you have. Then you can give it a try. Yeah. So if I remember, there will be something called I think in my previous lecture, it gives you do one simulation, then you go to another folder and submit another job. That should be doable.
Okay.
You know how to check how many cores you have, how many?
Actually, no, I don't know how to do it.
Yeah, could you open your Ubuntu right now? Okay, I can just easy demo to you. Yeah, you just say cat, C-A-T, cat. Wait a second, I may can find my show. Let me see. Let's see more. Okay. Let's chatting. Okay. Yeah, cat your slash PROC.
PROC.
Yeah, and slash CPU info, CPU info. Yeah, all into one word. CPU info. Yeah, info. Enter. No, info. That's all.
Info.
Mm-hmm.
Okay.
Info. Yeah. They do that again. Yeah. info. Yeah.
info.
Yeah. You have a. Yeah, you see, you can submit eight jobs in the same time. So more or less, you're from 4x4x4. You have one temperature, then your submits one job, then you take send at the end. Then you can go to another folder to submit another job.
And how can I do this?
Let me do. I request remote control.
Yeah, you already approved.
No. I think. Okay. So, what's the? Okay. So, for example, this. Let's go to T2. All right. 4x4x4 T2. All right. Then, for example, we'd like to run the job. For example, all right. For example, we'd like to run this job. I think you should, for example, we do SLOPT. Where's OPT?
This one, doctor.
No, yeah.
The last, yes, this one.
For example, this one. All right.
Yeah.
Next to. All right. I do just demo for all your guys. So what I do this. I use a shortcut. No.
Here's what I found on the web.
Ridiculous. 1 second. So I will use that as Monte Carlo, all right? Why you do not always torture yourself? Make it as simple.
I'm not torturing, doctor. I just copy and paste for the previous procedure.
All right.
And that's it.
Yeah, now we might much easier, right? So DLM, we do this. Right? What do you do have a send at the end, right?
Okay.
If right now we do the enter, we do the simulation, then we go to another folder. Can I do the testing right now?
Yeah, yes, you can.
Just for demo, all right? Because yeah, for example, I do this. Yeah, you see it will running already. Right? It's running.
The first one.
Yeah, the first one. Then you go to
and
another.
I go to the another. Okay.
Yeah.
So
So another. Okay. Then whatever. Then you go. You can have 8, right, in the same time.
8 of them.
Yeah, 8 of them. So
Uh,
you can do this, save your time. If you have
it will be great.
have
Saving.
one site, then you just do 8 points in the same time, right? Then you can easily do that. This is the way.
Okay. Doctor, my first critical temperature was 1.885, and for 444 it comes like 1.905, and for
Yeah,
the
it will
next,
be something like that. If that will not be too far, it will not be that very far, right? Like say previously said one is around 1.85, another go to 4. You know that will not happen, right?
yeah,
In fact,
and
it will not have that much change.
and for the lattice plot, should I make it just for 555?
Yeah, for the after the system size effect, then the others you just fix 1. You just do 5 by 5 by 5. That's fine. Yeah.
Okay, and for 66 and 888, I don't feel comfortable to do it in my laptop. So I don't know. I think I will not make it. Is it fine?
Please
I will stop
do
to
it.
555.
Please try your best to do it. As far as I know, if you use 2 million, that's still be okay.
Yeah.
As far as I know, yeah, you can do that. Yeah, it will. You will use your notebook. It will about 2 minutes for one run.
You know, doctor, because when I tried 888, my laptop hangs and I have written something in the Word and in Excel, everything goes and lost. So I made everything again, and I didn't want to be in this situation again.
Okay. I encourage you guys, once you know how to do it, try your best to finish. Yeah, try to
I know, doctor, the way, and I know how to do it, but the problem
Yeah.
is, as I said, it's technical problem.
Okay. All right.
In my laptop.
Try to make your work better. Right. That's what I thought. Yeah. Yeah, that's what I can say. Yeah.
Okay, doctor. About this one, how can I know that he's finished? He done the first simulation. If I made, for example, 8 simulations.
Okay. Now you use top. If you see nothing there. Yeah. There's no DM, so it says it's finished. And once it's finished, you will see it have done. Yeah.
Done. Okay.
Yeah.
Okay.
Yeah, you can easily find. Yeah.
And let's go for the Oviedo now. Last one.
Yeah. I think you're on the right track. Just be a little bit patient. You can do the simulations one after another well, right?
Yeah. I hope I can. Okay, no problem. Yeah. I will be patient.
Yeah. Do not be panic. How you do your finish your reports. Yeah.
Doctor, about the report, in the introduction, what should we write? What do you expect us to write in the introduction?
The introduction, as I said, you need about a few hundred words, right? To give the introduction. What's the melting? What's the phase change? Right? What's the why your job is important? Right? Why this simulation is useful? Right? Something like that.
Okay, because I wrote about the simulation and Delmento, and like it was introducing new vocabs and new.
All right. Yeah,
It's
you
fine.
need to spend a little bit of time for this. I will not give you a standard answer, right? Each of you.
Yeah,
will
I
write
didn't want
your
extended answer,
different-
but
yeah.
okay.
Yeah. This is the introduction. Yeah. All right, and then give the. I think you guys have done the some like term papers before, right? Yeah, something like that.
Yeah.
You should write like a paper. Yeah, term paper.
Okay, now, Doctor, how could I make it separated? How could I separate the atoms as the picture in the project file? You change something in the.
Yeah, the
you
particle
change something.
particle type. You change the size.
Okay, particle types.
Like a point 0.2 or 5. That depends. You see. The radius. Yeah. Then you just do play the movie like this. You see. All right. Just give you a visualization.
Doctor, is this requested to provide it in the paper?
You'd better have a screen snapshot. Yeah, for that. We do not need you to put the movie, but you say you just need to roughly state that before the critical temperature we have a crystal, and it's quite regular. You give 1 or 2 snapshot, then after transition you'll see it's melting. You will find the irregular, right? You'll see the amorphous. This snapshot, you can take the snapshot. I do not need to tell you how to do the snapshot, right? So,
yeah, sure.
Okay, you just need to demo, right, the different structure. You need to convince the reader who would like to read your report to say, okay, we find something different. One is crystal, one is liquid. So find the difference. Just give you as a demo. This also give you guys what you are dealing with. Right? You will feel a little bit comfortable. What you can visualize instead of just numbers. Right now you saw something.
So, Doctor, here it's after melting temperature. It's looking like crystal, not that amorphous.
Yes, this one is hard to tell. You will see it's vibrate around the equilibrium. Yeah. So if this, I'd like to say this time is still crystal because it do not have cross. It do not have jump from one lattice to another. It's still crystal.
Okay.
Yeah.
Okay, so for the phase change, you said how many points should I plot, or how many temperature should I plot?
You need to a little bit more than 7. A little bit more than 7. Yeah. Right now
Like
you have 7, right? You need to be. For example, if you want to have a line, you should have 5 points. So I'd like to say at least you need to have 10 points to have this critical change.
Okay, and the increment should be like this 0.05 or 1 or whatever. Does not matter.
Yeah, that depends how well you want to pin down the critical temperature, right? Yeah, 0.05 should be okay. 0.05 for each.
So the lower the better, Doctor. Or
yeah, I will not give you a formula like how much. Yeah, please try your best. All right, if you want to do it, you will do it well. Yeah.
Yeah, no problem. Okay.
Yeah. I will not
Thank-
give you a full template. Right? I think all of you will do it in your unique way. Each of you have your own parameter. Your data will be different from others. So it's hard to give a formula. Right?
Okay.
Yeah, but I can tell you are in a right track. All right. Spend a little bit of time on that. You will have a good report. Right.
Inshallah. Okay. Thank you, Doctor.
Yeah. You're welcome. Yeah, you're welcome. Yeah.
Doctor,
yeah.
I have
Misha. Yeah.
yes, Doctor. I have an issue with my Python code. Let me show you to get the mean value of the energy.
Okay. Please share your screen. Let's see if we can have. Have you seen the after Ganis just showed his Python code already?
Yeah, I did,
first one.
and I'm actually copying the code. I've taken the code from the previous tutorial.
Okay. Yeah, you will see the similar. So after Gani, can you please give him some help? Because I saw you do your plot. It's good. Yeah.
So, what do you need, Mishal?
To get the mean value of the energy or the energy value.
Okay, I can copy the Python code and paste it in the chat.
Yeah, that will be help. Yeah.
Yeah, no problem.
That would, thank you.
Doctor,
yeah.
First of all, the melting temperature is just expected to differ, right? As we increase the size, so not necessarily be higher. It can be lower because I think
It cannot be large. It's not high. It's around the 1.9. Yeah. No matter what's your parameter you have, I designed. It's around 1.9. It's not that change much.
Yeah. In 3x3x3, I got 3 point something, but 4x4x4, I got like 1.78, something like that. So that's normal, right?
And it doesn't look like quite normal. As I said, it's around 1.9. Yeah.
Even for the small size.
For small size, it still will be around that. Yeah, it's still around 2. Yeah.
I got 3, and it's so.
Could you please show yours? I think there's something. Let's see. Maybe I'm wrong.
Okay. The 4x4 many points were deleted, but I remember the pattern was like that.
Okay.
Just a minute. Share screen. Can you see it now?
Yeah, I can see yours. Yeah.
So the blue one is the 3x3x3. This is the transition. This is the transition temperature. Here it seems to be happening here, about 1.7 or so.
No, your jump is very small, right? It should be have a larger jump. Yeah. Wait 1 second. Wait 1 second. So your x-axis 0, 1, 2, 3, 4, and you have something. No, that's something is too much. That's too much. Okay.
Is there a convergence for the unit?
Yeah, the units. Okay, let's see.
Even if I convert them by epsilon is about 1, so not much change. No.
I see. You tried a lot of points. You go to 27. Do not explore that high temperature. It's always goes around 2. All right, goes around 2. So let's go.
Because I went high because it initially looked linear, so I kept searching. These are just remains.
I see.
Yeah.
You go to another direction. You go to lower. Yeah, go to lower. Yeah. You will get more points, and you have get results. Yeah, but how you get these points? How you get this data? Yeah. Could you please show
So,
me
but
your energy worth the MC steps? Could you please
this
show
jump
me?
is fine now. It looks fine now, right?
Jumps looks okay.
Sorry?
Yeah, jumps looks okay. Yeah, but let me double check your data. Double check your data.
The
Your
code's
MC
working now,
steps.
but
Yeah.
MC steps.
Let me show your data. All right, please show me your data.
So the
you
Python,
have
you mean?
the energy worth steps. Yeah. Let me see your equilibrium. Yeah.
Just a second, the sharing thing.
Yeah.
It's not.
Abdul Ghani, thank you for sharing your code. Your code works well, right? For the others, please know how to do the average. But I'd like to type one. There's one called STD, right? So
no
STD,
problem, doctor.
yeah. So you can use sp.std. Please find out something around that. Standard deviation. That's the one is also very good. So that will tell you how good of your average. Right? Sometimes you have a small standard deviation. That means your data is much better. Right?
So this is the data. This is with the cutoff. I cut it at 1 minute.
Could you please show your whole steps? I mean, okay, more or less you already got equilibrium, but I'd like to see your whole.
Yeah, but it's working now. So, and the point I just worked is around the critical temperature. So the blood is less stable.
Wait one second. Wait 1 second. You have n equals 5. Y is 500. So you do 5 by 5 by 5, right? No, you will see your.
Yeah, no, this is the full thing for something around the critical
something
temperature.
wrong. Yeah. Do not go there. If you do this, you will see your system have not been equilibrium yet.
Yeah, I didn't do this. You just asked me to do it from to show you from the beginning. I do 1000, and for this is only unstable because I'm around the critical. But in the previous ones, it's stable. This is around the critical temperature, so it gets unstable. This is what it usually looks like.
Yeah. So you will not say just do the piece of them from. I mean, if you get equilibrium, you will do no matter how long you go 10, you go 100 million steps. It will all like a fluctuation.
I don't take the equilibration. I only wait until like cut off until it's stable.
So yeah, once you do the average, make sure your data is good already. Then you do the average. Otherwise, you need to redo the simulation.
Yeah, but this is good. Like if it's look like this.
This one is good. Right? This one good.
Yeah, they all look like that. Yeah.
Okay.
They all
Wait
look
1 second. Let me have a look at your code, right? To see. Yeah, your code. You have this. You have K. You have ints 1000. Why you have 1000? Yeah, okay, 1000 because you have the step.
Yeah.
From the Abdul Ghani's code, it's similar, very similar. It clearly shows why you need to take 1000 because that's 1 million. Right?
Yeah.
Then K1 divided by N takes out the per atom. Then you have steps, cohesive energy, legend, then MA, take the average, then plot. Yeah. Your code, your plot is good so far for this one. What's the temperature for this one? For this energy?
I don't remember, but probably like 1 or 2, something like that.
Yeah, please also always put that in your folder as a folder name, and also once you have the energy dot data, you put the energy dot
Oh, so we will upload these. I overwrite them, so I will write
I
any
see.
temperature over the same folder.
Yeah.
So that I don't need to move it from one directory to another.
Yeah, I think it's better to keep the original data. Yeah, this data is still very small. I mean, compared to your hard disk. Yeah.
Yeah, but even when I say cut it at say no, the current won't work. But if I change it to 600, 500, the number doesn't change much.
That exactly the spirit of this installation. No matter you change, your
So,
result will not change.
yeah.
Yeah. Okay.
So that must not be the problem. Something is so
that make your data reproducible, right? So sometimes people they have their own setup, but the main conclusion is it should be the same.
Yeah, but and now the jump for the 5 by 5 by 5 looks even smaller. Looks very tiny. Like less than 1.
Yeah, please, each of your data, you should clearly check it become equilibrium, right?
Yeah, I check with all of them for sure.
Then you use that data to do the plotting.
So no, it doesn't matter if it's like less than 1 EB, the jump. And there's no conversion, right? The data we will get is EV directly.
The data will not change much away from 3 by 3 or 4 by 4 by 4. You will see if you're eventually you will have one data to plot all of them into one figure. You will see they are not changing much. Right?
Yeah, I know. But I mean they jump within one size. If it becomes smaller, like just a second.
Yeah, the jump will be around briefly 1.8 to 2.1 in that range. All right.
No, I mean the magnitude of the jump. Just a second. So here the two, it seems to be happening around here, so the jump will be just this much. So that's fine.
Yeah.
But the jump here is like comfortably bigger.
Yeah.
Here it's small.
Yeah, the jump looks like small, but if you're zooming in, it is still be okay. Yeah. You need to find something. You need to refine your data. Yeah.
Okay. And for the volume, for the density, I saw something we get the volume with. So I just take the reciprocal.
Yeah, for the volume change, that's another. That's do MPT. That's another.
Yeah, I know. But like
for MPT, just do the one size, 5 by 5 by 5. Yeah.
Yes. But the task says find the density.
Yeah.
So just take the volume and take the reciprocal.
Right. You just do one. Yeah, just save you guys a little bit time. Yeah.
So we use the function that calculates volume and then takes the reciprocal of that data.
Right. Once you have such energy, then you will find something similar, right? But just for the density or volume.
Yes, just take the reciprocal volume and move on.
Yeah. Just will demo the jump, all right? The jump. You will see something similar, but they are all about jump. This jump means the phase change. That's what we give you guys.
Yeah.
The demo. What means phase change? All right. Yeah.
All right. Thank you.
Yeah, you're welcome. I think you are in the right track. Please go ahead and polish your data, polish your report.
Okay, thank you.
So Ahmed, I think you're on right track, right? Yeah. Right. Someone next. Michelle, I think you will do good, right? Once you're finished how to do the average, etc., it will be fine. Yeah. Sad. Do you have anything to ask? Hassan, do you have something to ask? Hassan. Ahmed. Okay, someone next, if you have a question, please let me know. Yeah.
Doctor, I'm going to log from my computer and I will show you my results for the 3x3x3.
Okay, please go ahead. Yeah, asking. Yeah.
Okay, just one last question. In the report, do we need to talk about the details of the method we use, like Metropolis steps and all that, or just why is this important and how did we carry it out and what's the conclusions of our data?
Yes, in the introduction, you need to tell others a story, like tell yourself how I do such exploration, how I find the phase change, right? So important, etc. Yeah.
But like the technical details, like the Metropolis method or criteria and these things, are they important or defining like what's the radial function exactly?
Yeah, I think once you learn this in your fresh memory, please try to write as more as you can. So maybe 10 years later, you can still read what you are doing in this month.
Okay.
It's not for me, all right? For something for you. You will learn this project. This is so important. Many years later, you can still remember. We do a good job in finding the melting temperature, right?
Yeah,
How
I
to
see,
do that?
Yeah, I see. Thank you.
Yeah, please share your desktop. Let's see what's your question. Hassan, yeah, please go ahead. I think you have still have difficulties. Yeah. In the meantime, someone else have questions?
Yes, doctor.
Yes, Misha. Yeah.
Yes, when we are doing the MVT to get the phase change, and we move to do the size effect.
Yes.
Do we take it close to the melting temperature so we can find the jump?
Yes, you should do around the phase change as your smaller size. All right, around that. All right, then you will find similar to identify at the new size what's the new transition temperature.
Okay.
Yeah, I really appreciate your T2. Yeah, this one is a very good demo. How to do the average. Yeah, how to find the equilibrium. Yeah, you will see you only take the data after 0.5 million, right? Yeah, that's after that, it's production phase. Previously, it's noisy. It's just trash data, right? And you cannot use that. If you use that, you will get wrong data. Yeah, thanks for sharing for this. All of you just need to plot and find your equilibrium phase, find your production phase, and take that as your final data. Yeah. That's a good demo. Yeah, thank you. Yeah, if you have done 3x3x3, then 4x4x4, 5x5x5, is that?
Oh, doctor, I was muted. I don't know.
Sorry.
I was talking the whole time.
Oh, okay, sorry, we have not hear you. Yeah. Okay.
Sorry. Okay, see. So I did this for the 3x3x3. I started from 0.5 Let me show you.
Yeah, please show me your.
I did this 3.5.
Yeah.
I did all of these temperatures, and
Okay.
I noticed the change in 1.75. You can see it here. This is 0.75, 1. All of them are stable, but until it reached 1.75.
I see. Yeah.
There is a jump.
Yeah.
And then 2.
Yeah.
It started somehow stabilizing
Yeah.
here after 200,000.
No, we'll do the well equilibrated. Yeah, you need to take the data well equilibrated. Sometimes you need to go to Monte Carlo steps up to 2 million.
Yes, for example, here I need to do it after 400,000, right?
Yeah,
So I take
to
this
go.
part.
Even more than that. It's safe to take around 0.5 or 0.6. For example, you're 0.6. You're very
somewhere here.
Yeah. And you can extend the Monte Carlo steps. You can take 2 million. Then you have more data to do the average.
I did the 2 million for the
4x4x4.
4x4.
Okay, that's good. Looks much better. You see.
This is for the 4x4x4.
Yeah. You will see if you take 1 million step at t equals 2, right? You will see it's not enough. If you take 1 million, you will see your average data may not be enough. So that's 2 million. It looks good. You see.
So, for example, doctor, if I want to know which value from my array corresponds to the 500,000.
You need to find out. Yeah, you need to plot the.
I think this is
step. Yeah.
If I do it like this.
Yeah.
Here I specified the period for taking this much.
Oh, so, I think that may be too large. I mean, your data, you do make smaller, 1,000. 1,000 should be fine.
In this one.
1,000, if you take 5,000, you take less data.
Yeah, I know, because I want my size of array is 400. I think 400 gives accurate results. Like I have 400 data points.
That's it. Sometimes you can take more than that. Yeah, you can take more than that. It's fine.
But I think this is even good.
Okay, looks good so far. Yeah, looks good. Yeah, that's why I do not give you a standard answer. All this data you should explore by yourself. That's something you have your own investigation. Even for the large projects later, if you are even in a leader of a scientific team, you do something similar to this, right? Find something that when they have phase change. Right now, you may find it's 1.9, but sometimes say, what's the precision? Can you go to 4 digits? So you do, if you want to go 4 digits, then you have another strategy, right? You need to pin down how to do that. But right now, I do not give you such requirements. You can do roughly something that depending on your computing resources and depending on how well you want to.
Yes.
Yeah, it's fine. Yeah, you use point.
So you see here.
Yeah.
See here.
Okay.
This is the 1.75, the temperature.
Yeah. Okay.
And
1.75. Yeah.
I took K. See, so from here.
Yeah. So you're eliminate the first 180 points, right?
Yes. And for this one, I took 50. So I was taking care of this.
Yeah, you need to well define these ones. I think previously after Gani, he gave you the code. From the code, you will see you need to define the steps. How many steps? If you go to the chatting zone, after Gani, he paste his code. You will see the keynote is 100. If you change that one, you do something similar, so you can let yourself know what you are doing. I just pasted that one.
Doctor, I couldn't hear you. My speakers turned off.
Sorry. Yeah, if you go to the chatting, the chat session, the chat.
Here.
Yeah, you'll see that K naught, right, equals 1,000. In your case, you'll use 5,000, right? So make this clear in your script. That will help you.
Oh yeah, I got what you mean. So you mean for if each time I want to change, I just change one thing.
Right, something like that. So make the code readable to yourself.
Yes, okay.
Code just for yourself, not for me. All right. So
I know. I will do it later.
Yeah, I think all of you, all the students should know like this. What's the equilibrium, right? Do not take data before equilibrium. Take data is well equilibrated, then you can use that. Otherwise, you need to extend your simulation steps and get the system equilibrium, right?
So okay, for now, for this 3 by 3 by 3. Now, can I conclude that the transition temperature is somewhere between 1.75 maybe?
1.75, yeah. Then you can pin down to do more investigation, yeah. You know,
Then what?
then you can do more investigation around that temperature, right? You know, the phase change happens around that.
And also using the visualization from Oviedo as well.
Use Oviedo, even you do more investigation. For example, why not take a 1.7, 1.8? Then you know it's clear shows the point, right?
All right. But overall, you think my
yeah, but I can see
are
you
good?
are in a right track. You're in the right.
Okay, good.
Yeah, it just need to be play a little bit more and polish your data and your report.
And okay, I will show you something as well.
Something. Okay, please go ahead.
This is the data for.
Okay,
I plotted
sounds good. Yeah,
temperature versus.
Yeah.
Energy.
Everyone should do this. Although in this plot it do not show the clear large jump, but if you zoom in, you will find there are jumps, right? If you are doing clearly there are two different straight lines. Yeah, that has a jump. Yeah. And you can take the temperature a little bit more denser. The data points denser. Then you can
clear.
Yeah, you do not take. Maybe you can say 0.05 step. Then you have a very clear, very sharp jump, right?
Okay.
Yeah, you do not do it around 0.5. You just around 0.75, right? Just a few more points. Yeah.
Yes.
Okay. All right. Thank you for. I think all the other classmates learn from your case. Awesome.
All right. Thank you, Doctor.
Yeah. For the another one who have want to share your work.
Yes, me, Doctor.
Yeah, Eunice, yeah, please.
Yes. Do you see my work here, teacher?
Yes, I saw your
how do I make this one dotted? Or do I need to do as my fellow? I go to Excel and plot it.
Okay, you're still doing a very good one. Your C is more or less
this is
a large jump. Yeah, it's
yes.
a large jump. Yeah, you should do something like just as Hashi doing. He do 0.5. You may see you have a very low temperature one, 0.5. Then you will see you start from 1.7. That's not sounds good. So if you do a few points in the lower temperature, like 0.5, 0.8, then 1, then you will see clearly shows the difference. All right, so it's a trend.
Okay, but how do I make it dotted? You see it is now a straight line, or is it acceptable as a straight line, as a line actually? This line, I mean the graph.
Okay, you do not need to plot in line. You just put in dot, right? You're a human being. You can catch it by your eye. Yeah, from your eye you can check it's a straight line. You don't need to plot in a straight line. You just put it in dot. Yeah.
Okay. So I am now my my job is right.
Yeah.
I did it.
Yeah, you have yeah. I think looks
About
good.
here, the temperature in here. I mean,
That's great. That's a very good demo to see the equilibrium, right? Before the critical temperature, no much change. Then after critical temperature, you have the clear phase for the equilibrium and go to fluctuation, right? Yeah, that's good.
So I only need to add lower temperatures. No larger temperatures.
You need to do both. All right.
Both?
You have a few points. Go to 0.5, going to 1, going to 1.5, something. Then you also go to a few, go to 2, 2.2, 2.5, 3, something like that. You just do not go to too high. Just around the 3, that's enough. Yeah.
Okay.
Yeah.
Thank you.
Then you need to have more points. Then once you plot it, everyone can catch it. Yeah, catch the jump. Yeah.
Okay. Thank you.
Yeah, you're on the right track. Please go ahead. Yeah. Okay. So Eunice, yeah, okay. Someone next? Yeah, as I said, you should say, yeah, your cat K0 is 2000. Have you clearly know your step in your control file you use to out every 2000?
Me? No, it was 1000, but I put it 2000 just to make it easier.
Oh, okay. That's
I have it 1000 in the control file.
I see. Okay. Yeah, you need to find your own way. All right. That's why I do not set the standard. Yeah. Okay. Yeah. You only know the code by your own, right? Don't really.
Yes.
Yeah. Okay. Good. Yeah. Other questions, please?
I also have a question about the NBT and the RDF. We only do it for one. We don't do it for the rest.
Yeah, for MVT, then we do side effect. But for NPT, we just do one side, 5 by 5 by 5. All right, please. Yeah, for NPT, we just do one size. Yeah. And I believe you guys know how to do the size effect for MVT. You already know how to do NPT, right? Just save you guys a little bit of time. Yeah. Other questions? I'm happy that you all got a good progress. All right, I'm so happy. Yeah, please just spend in general. If you have this ready, you only spend another a few hours, like 5 or 6 hours. You can get all the data, and you will spend another couple of hours to finish the report. You guys are right track. Yeah, I'm so happy. Yeah, please go ahead to finish your report. Yeah. If you do not have further questions, we can close this session. I saw Michelle, Hashin, Abdul Ghani, you all do good job. All right. Yeah, Michelle, maybe do you still have questions? Michelle.
Doctor.
Yeah.
For calculation for the calculation in the lattice constant sigma, should we find the volume from 555, the volume, average volume, then divide it by how to say it?
Yes. I think you already answered the question. You asked the question. Yeah, we should use that formula. Yeah, that's more.
We take the third root and divide it by the volume, the 5 multiplied by 5 multiplied by 5 over the volume, all inside the third root, and we will find the lattice constant, not the lattice constant, the sigma.
Yes. You can paste it here. You can paste it here if you I'd like to double check.
I don't know.
In the chat still.
Yeah.
Because that one is robust, not only for this simulation, it's also for all other simulation. You will see. Yes.
Not over 3, over 1 over, how to say it?
Yeah.
1 over 3, like this.
Yes, cubic, yeah.
Yeah, the cubic root.
Yes.
Okay, that's good. And we find the V average same in the same by the same code to finding the E average, the energy average. The same code
energy average. I think in the code you already.
Yeah. That you already listed. Just fine. Okay.
Yeah.
Just to double check. Thanks.
Yeah. Okay. Yeah. Let's go ahead and complete your report. Yeah. You need to take about 1 day to get a good ones. Yeah.
Inshallah, it will like you. Inshallah, it will. You will like it. Sorry.
Great. I will be happy you guys make a good progress.
And do we need to do a home page for the report, like I don't know, KPM logo or something?
Whatever you like. You think good. All right. To make your individual be more fancy. Whatever you like. All right.
Okay. And I will warn you from now. You may find troublesome in my English writing. It's not that good, so please.
It's fine. Yeah, it's fine. Yeah, try your best to write. Then, if your data is unique and good, I will give you full credit. It's not for English, right?
Yeah, inshallah.
Yeah. All right. And please go ahead. And I'd like to close this session. All right. Thank you. Yeah. I think Misha, you already asked the question, right?
No, I didn't actually. I'm here sitting and listening to my classmates if they have any interesting questions.
Okay.
So, no, I'm still working. Yeah, on the side effects, there is a problem.
All right. Really appreciate you guys do good progress. Yeah.
Thank you.
All of you already know how to do that in different systems. Do not be panic. The simulation runs really quick. Even sounds big number, millions steps. Computer runs really fast about that. Yeah.
Doctor.
Yeah.
Can I share just a little bit? I have got here, I don't know, what does plus and minus means here?
Okay. I don't know. That side in general is just the plus and the down. Yeah. I think it should be fine. No worry. If then it's finished. No worry. Yeah.
Because it's already, he said, finished above, and he's what now minus and plus.
Yeah. Should be fine. No worry. Okay. Wow, you're so good. You're learning so quick. You have 7 jobs running in the same time.
Yeah, you learn. You teach us very well.
Yeah. As I said, you do not need to copy and so long comment. All right, you always use a shortcut. Use
Just one click, Doctor.
said,
Just
yeah.
one click, so it's, it's very easy.
Okay. Yeah. Because eventually you will learn Ubuntu very good. You will have a lot of your own comments. That's make your Ubuntu very, I mean, just for yourself, more or less that. No one know how to do that. Yeah.
Personal.
You do the work very quick.
Okay. Okay, Doctor, thank you. And will you be available in Telegram if I have questions or something?
Yeah, in general, I'm in the Telegram. Yeah, I will. Yeah. Please paste your question to the group. In general, I already have a lot of you classmates. I ask them, like you, I will encourage you. If someone else have a question and you have go through the difficulties, please share your experience and help others. That I think all of you will get or learned, right? And be collaborate later. We will in a good group, right?
Yeah, we're in one group, yes.
Yeah, yeah.
Okay, Doctor.
Yeah, have a good night, all right?
Inshallah.
Yeah, all right. I like to close this session. Yeah, bye-bye.